Steve Diamond. He's the head of the IEEE Computing Cloud Initiative, and he's going to provide us a very good presentation on this. I'll give you his background. Steve is the founder and chair of the IEEE Computing Initiative and the IEEE Cloud Computing Standards Committee. Steve has 30 years of senior management, marketing, business development, merger and acquisition, and engineering experience in computers, software, semiconductor, and standards. He is the general manager of the Industry Standards Office and Global Standards Officer at EMC Corporation. Prior to EMC, he was the Director of Product Management for the Intercloud Computing at Cisco, where he was responsible for Cisco's cloud standards program and built Cisco's first AWS cloud computing system. Before that, he was VP of Marketing at Equator, and now he's authored over 20 publications on cloud computing, memory, and microprocessor technologies, signal processing, expert systems, and computer graphics. He is the past president of the IEEE Computer Society, twice served on the IEEE Board of Directors, was the founding member of the IEEE Standards Association Board of Governors, and was the editor-in-chief of the IEEE Micro magazine. Steve was awarded the IEEE Third Millennium Medal and the Computer Society Golden Core Award. Let's welcome Steve Diamond.
Thank you, Steve, and good morning, everyone. I'm thrilled to be here to talk about the IEEE Cloud Computing Initiative. I think another way to understand the introduction that I was giving is that I'm almost eligible for the IEEE Life member status. So I'm glad to be here in the waning years of my paid IEEE membership career. I'm glad to see a mixture of chronological parameters in the audience. Usually when I come to IEEE conferences and talk about history leading up to this point in cloud computing, I usually see a lot of people who may not have lived through the tumultuous changes that have brought us to this moment in cloud computing, and so sometimes the historical allusions don't resonate with people. So here, I hope some of you at least will remember some of the things I talk about leading up to the present. Since this is a consumer electronics group, I thought I'd start with a consumer electronics allusion. And so I'm going to show a picture of a piece of consumer electronics equipment, and I want to ask how many people in the audience, other than knowing what kind of equipment this is, know why this is an important piece of consumer electronics gear. Okay, I see two hands. So the rest of you, I think, we may have to provide remedial information on the rest of my talk. I'm a little concerned now. So this is the Sony CDP-101. And the reason that it's important is that it was the world's first consumer commercially released CD player. It was released in Japan in 1982 and released in the rest of the world in 1983. I happened to see it at the Consumer Electronics Show at Heinz Auditorium in the summer of 1983, and I was amazed because Sony had set these up on tables and provided one of the 6 CDs that were available on release, I think, and a pair of headphones, and you could listen to it. And I'm not an audiophile, but I was really amazed at the audio quality innovations happened. At the time, in 1983, I was general manager of the group at Synertech, which was a semiconductor company that built microprocessors, among other things, and we were the largest supplier of 6502 chips to a company called Apple Computer. And we were looking for a way to expand our market into new areas, and it occurred to me while I was in Chicago that summer that because this new CD wave was happening, probably the consumer electronics world in building a lot of CD players was going to make a lot of CD reader hardware modules. And in those days of computing, the storage mechanism was a floppy disk. It was, I think, 360 kilobytes of information on a double-sided floppy. If you had a single-sided, it was 180 kilobytes. Not very much storage. And it occurred to me that instead of having 20 floppy disks to load a program, now it would be hundreds, of course, couldn't we just put that information on these CD media? They were almost gigabytes, 700 megabytes or so. And I talked to my colleagues back in Silicon Valley, and they said, well, the world's expert in optical storage is at IBM in San Jose. You should go talk to him. So we went to talk to him, and I said, I've just seen the future, and it's this high-volume CD world, and there's going to be a lot of players made, and it's going to drive the cost of these CD players down. And shouldn't we build the silicon to turn that into a CD-ROM device, and we do away with floppies? And he told me it was really interesting. IBM had been thinking about that, and it was not possible to build a CD-ROM player because the error rate would be too high, and so don't worry about it. It's never going to happen. So I just want you to know why it's not possible to have CD-ROM players in PCs, because it's never going to happen. Well, it turned out he was wrong, and I was wrong too, because I didn't, after talking to the world's greatest expert, I didn't follow up. But innovation in our business is something that goes in fits and starts. But there is a pattern in what goes forward. And that's what I want to talk about today, not the mistakes that I made in the past. So this is a slide I've been showing for quite some time about the waves of computing. I think we're in the fourth wave of computing, and that wave includes cloud, mobile, social, big data, and Internet of Things. And it's a wave that has been going on for some time, but some of the parameters and some of the characteristics of the transitions are similar to the previous waves, and I want to talk about that today. But in particular, what I'd like to discuss is what we need to know about this wave of computing and how to make it succeed, as I think we would agree that the Internet has succeeded. IDC has been talking about sort of three platforms of computing, and actually I think that's a useful way of looking at computing, and I'm going to talk about what that means to the cloud computing wave and what that means to all of us here in the consumer world. The first platform, as IDC calls it, is the platform of terminals, mainframes, mini computers, and terminals. That little screen on the right is meant to represent what you saw when you sat in front of a VT100 or a VT52 or an ADM3 terminal and typed your commands into the terminal, and then you hit enter. In that world, there were thousands of apps and millions of users. How many of us were involved in that wave of computing? Okay, quite a few. So this won't be unfamiliar to you. If you remember back in those days, at least to me, it seemed miraculous what was going on. But it really was just the beginning of what we're seeing today. The second wave, with tens of thousands of apps and hundreds of millions of users, was facilitated by the LAN, client-server, Sun Microsystems, Apollo computer, and so forth, and the PC. So we had order of magnitude increase in the number of apps, orders of magnitude increase in the numbers of users. That's the second platform. The third platform is where we are today. Applications go to millions of applications, billions of users, but what's really interesting is the things, hundreds of billions of things. These are things that we've heard this discussed a lot this week at the Consumer Electronics Show. Internet of Things, but also social, cloud, and mobile. The interesting numbers here have to do with how much data is created per day. This was a 2012 number, but the 2.5 exabytes of data, that's 1 billion gigabytes of data created per day, is an interesting number because if you divide that by the number of people in the world, you find out that there's half a gigabyte of data being created per person in the world per day. That's a lot of data. And the question is, how do we make this really work? Because there are a lot of stumbling blocks on the way from the second platform to the third platform, and if we want this to be successful, if we want to have products that take advantage of this world, we have to think about what happened in the past and figure out what we need to do today to facilitate this. Ray Kurzweil talks about the evolution of the human brain as expanding into the cloud. He doesn't mean that we're simply going to copy information into the cloud from our personal lives, or we're going to get information from the cloud onto our smartphones. He's talking about a collaborative, federated network which extends from each of us into the cloud. That's the potential that we can implement. What do we need to do to make that happen? I think we have to look at what happened in the previous waves and understand what the impediments were to growth and do what we can today to make those impediments go away. Of course, it's not exactly what happened in the past, but it's the theme, it's the rhyme of what happened in the past that we have to pay attention to. And so what I'm going to talk about today, and what I'd be happy to answer questions about until Tom comes up and yanks me off the stage, is what are the rhymes that we're going to be seeing going forward in the future, and what can we do about them, particularly in the IEEE, to move forward more quickly and avoid the pitfalls that we had in the world of the internet. So, how many of you were involved in the first communications telephone exchange in 1878? Okay, nobody? Oh, one person. Okay, good. So, I wasn't there. I was around in 1961. It took from 1878 to 1961 to get from the first commercial telephone exchange to international direct distance dialing. For those of you who weren't here in 1961, in the pre-IEEE days, if you wanted to call to any arbitrary telephone around the world, in many cases you'd have to go through an operator. You'd call, an operator would come on the line. The operator would then have to hook you into a new system using a patch board and complete the call. Sometimes it would take more than one hop. This is what I would call a non-federated operating system. In 1961, you could make a call anywhere to any telephone without the intercession of an operator. And that was essential to making this system work. And I'm going to claim that this is essential to making the world of cloud computing work. In 1980s, how many of you were involved with used email in the 1980s? Okay, a fairly large number of people. In the beginning, if you were on one particular email provider, you couldn't send email to somebody else on another email provider. There were islands. And so you had to choose which email provider you wanted to be on in the beginning based on who else you had in your Google Plus community, your social network. Because if you made the wrong choice, you couldn't send them email. Well, you could send email to Bob and ask Bob to send email to Frank, and Frank to send it to Julie. Again, that's like the pre-international direct distance dialing system. So the fix to that was federation, the creation of standards, in many cases here IEEE or IETF standards that created protocols like TCP/IP, DNS, MIME, SMTP, and connected things together, and then you could send an email from anywhere to anywhere, almost. Cloud computing today is in the same situation. They're all connected on the internet. That's not the problem. But multiple providers don't offer a way to write applications that consolidate assets across the cloud. So I say there's no intercloud. Well, I'm not the only one. Vinsurf, who has a place in history as a visionary for the internet, tells us that we're in the same boat we were in 1973 when we were building the internet. So what does it take to change this situation? What do we have to do to make this happen? We need to federate. Federation, like with the international direct distance dialing system, federation like SMTP, TCP, and so forth, so that application developers can develop applications that compose resources across the intercloud, so that cloud resources can access other cloud resources without having to use pairwise interfaces. So let's talk about what that means in terms of APIs. There's the conventional approach, the non-federated approach, which I call multi-cloud. Here you have multiple cloud providers, you have multiple cloud users, and you have the internet. Each cloud provider has their own API. And if you want to write an application for a particular cloud provider, you need to obviously use their API. If you want to write an application for more than one cloud provider, you have to use more than one API. There may be cloud mediators, as I've called them here, whose business it is to create a single API that you can write an application to and track the development of these other APIs so that you don't have to. One of our colleagues in the Cloud Computing Initiative, Raj Kumar Bhuya, who's the EIC of the new Transactions on Cloud Computing, which I will be happy to give you a shameless plug to subscribe to, due out very soon, has a startup that he's working with that does just this. And Raj and I have had a long conversation about how difficult it is to track multiple APIs over time. It's possible he's in that business, he's a cloud mediator, but as the multiple cloud providers make changes to their APIs, and they're not standard, right? Each of these APIs are promulgated by a particular cloud provider, but they're not industry standards as we understand them formally, promulgated by an SDO. They may be a facto standard, but the control for that resides with the cloud provider. And if they make a tweak, a fix, a change to that API, then all of the users have to do the same thing. And when you multiply that by multiple cloud providers, it becomes a very difficult task. It's even a difficult task for the cloud mediator to keep track of that. Sometimes these things are really changing on a granularity of days. What that means is if you want to write an application that talks to the whole cloud, talks to multiple cloud providers, you're spending a lot of your effort not in designing the application, supporting your customers, adding features, but you're spending a lot of time on keeping it working in the first place. So imagine that you had an application that talked to 3 cloud providers, and you're spending a third or half of your time just keeping up with the API changes. That's going to retard the development of your applications. And if you believe, as I do, that cloud applications are going to need resources from multiple cloud providers, all the large cloud providers, to reach their potential, this is an overhead that will retard your development and the development of cloud computing. So, a few years ago, a number of us in IEEE asked ourselves, what could we do about this situation so we didn't have the email situation that we had in the 80s reflected into the cloud. And we came up with what was imaginatively called the intercloud approach. We had inter laying around, we had cloud, put them together, intercloud. Just as we did with inter and net. Not very creative, but there you have it. So here's the same picture that I showed before with 3 cloud providers, multiple cloud users, and we have a couple of additional features I'll talk about in a minute. So in the intercloud approach, the idea is that cloud providers would expose an intercloud API that would be a standard. This standard could be used by cloud users. There could also be proprietary APIs. We certainly, in the IEEE, believe in open consensus-based voluntary standards. So we're not saying that the cloud providers shouldn't have their own proprietary APIs. That's fine. They could have their own. But if they exposed one common intercloud API that allowed any cloud user and any other cloud provider to access their resources, then it would be possible to write an application that would compose resources across all of the cloud providers. And one cloud provider could access another cloud provider's resources through the same API. Now, I believe that in the future, the majority of cloud processing will be created by other clouds. In other words, clouds will arbitrage workloads to find the most effective, most efficient, most service level agreement compatible location for the work to be done. You may or may not be interested in where that work is done. That's part of the service level agreement, and that's something that the intercloud API ultimately has to deal with. But if you don't have to worry about that, if you're comfortable letting the clouds work this out themselves, it'll be possible to drive the cost of computing and essentially the results of computing very, very heavily in the favor of the users. And that's the intercloud vision, making it possible to get the most computing, the most big data, the most Internet of Things for a given set of resources. And the key to that is federation, and the key to that federation is the intercloud API. Same story as multiple internet providers, same story as we got with SMTP, same story as international direct distance dialing. It's not history repeating, it's history rhyming. Now, I'll take questions at the end. Let me be glad to. Let me also talk about intercloud exchange and intercloud gateway and intercloud route. The vision here is a creation of assets similar to what we have in the internet. Intercloud route is an asset similar to DNS. It's a way to get information about what resources are available in the cloud in a central, controlled, secure place. So think of that as DNS. Intercloud exchanges are assets that mediate governance on the intercloud. Intercloud gateways mediate data exchange. So these are central assets that would be available with interfaces to the intercloud API that give us the ability to share intercloud assets between intercloud providers and intercloud users. To make this work, it also requires, in addition to standards, industry associations, university partnerships, and we'll talk about in just a minute the intercloud testbed that we're starting. This is the genesis of a project we started a few years ago, the P2302 standard for intercloud interoperability and federation. That's the first standards project we started in the IEEE around cloud computing. And that includes the concepts I mentioned of exchanges, gateways, route, and so forth. And it allows you to design and build private clouds, hybrid clouds, public clouds that can talk to other clouds and other users in a standard way without having to build pairwise API interfaces that would retard development. I'd love to have more participation in P2302. There's the URL for the working group. Actually, the best way to learn about all of our activities in the IEEE cloud computing world is cloudcomputing.ieee.org. So you don't have to pay attention to these URLs here. We have a portal that we put together that encompasses not just IEEE's activities, but also many external activities around cloud computing and big data. But if you're interested in a particular activity that I'm talking about, cloudcomputing.ieee.org will get you there. Okay, a couple of other standards projects, and then I'll talk more generally about standards. P2301 is a guide that we have under development. It's a guide for cloud portability and interoperability, but basically the idea is to create multiple profiles of standards and point you to the standards that you might be interested in looking at of the very, very many standards that people are developing in the cloud computing space. So we'll have profiles along the lines of private cloud, public cloud, hybrid cloud, and point to the standards work that's being done at IEEE and elsewhere that we think is relevant to that work. So if you, for example, are tasked with building a private data center cloud in your company, we'll have a profile that lists the standards that would be useful for you to take a look at in this space. It's a guide, so the language in guides are not normative. They give you guidance about what to do. They don't define what you have to do to be conforming to a standard. And it's being chaired by John Messina, who's one of the leaders of the NIST cloud computing effort. Many of you are aware of the NIST cloud definitions, SAS, PAS, and so forth. John was on the team that developed those very important definitions that help move cloud computing along. And he's leading up that group. Again, cloudcomputing.ieee.org for participation. You don't have to be an IEEE member, although I hope all of you are. Anybody can participate in an IEEE standards working group without being an IEEE member or an IEEE Standards Association member. The other project that's just starting up as of January 1st is a project to study whether a standard in the adaptive management for cloud computing world is appropriate, and that's headed up by Joel Fleck. Joel is the Senior Standards Architect and Head of Cloud Standards for HP Labs. Again, cloudcomputing.ieee.org will get you there. That project is just spinning up. It's another piece of the puzzle that we identified as an important area for cloud computing. With the creation of these standards projects, based on the Mark Twain criteria, we realized that having the standards was not sufficient to make this all work in the real world, and we started, as part of the Cloud Computing Initiative, the IEEE Intercloud Testbed. The idea of the testbed is to bring together a number of industry players who are future cloud providers and users to try out protocols that would ultimately become part of P2302 or some other standards project in the real world, to feed information into P2302 and other standards, and to get information back and change how they work. In the old days of Sun, we used to call these connectathons. And this is the basic idea of the Intercloud Testbed. We announced recently 20-odd founding members of the Intercloud Testbed who are participating in the development of what will ultimately be P2302 compatible intercloud resources. People on this list are either bringing forward hardware, physical locations, researchers, etc., to contribute to the project. And again, if your organization is interested in participating, we'd love to have you. Please come to cloudcomputing.ieee.org and tell us what you can contribute to this project. I often get questions about standardization in general around cloud computing. There are folks who say it's too early for developing standards in cloud computing. We have a number of successful vendors who have cloud computing resources that are being sold and used. Why do you need standards? Well, I think in the consumer electronics world, we've had lots of examples of standards battles, some of which resulted in the creation of a lot of standards that were used, and some of them standards that weren't used. I found that looking at standards, you can always find people who think the standards are too early or too late. It's very, very seldom that somebody thinks that they're just right, as Goldilocks said. We think about this a lot in the standards community. There's probably 40 or 50 organizations involved today in developing cloud computing standards. Some of them have particular expertise in this world of standardization related to IT standards. Some of them missed the boat and were trying to get involved in the development of IT standards and may not have particular expertise in that space. The IEEE's philosophy about standards, as I mentioned earlier, is that they should be open, consensus-based, and voluntary standards, which means ultimately that the customer decides what standards are important by deciding what to procure. So what this also tells us is we don't really know whether it's too early, too late, or just right. But given the rhythm of the situation, we're trying to develop standards here in the IEEE that we think will be the right standard at the right time when we get to the right place. And we'll see. I don't think we'll know next year. Maybe the year after that, things will start to become more perceptible. The decision about when to standardize is actually a very complicated decision, and I'm not going to go into the details of this model, but I would suggest that Jim Gosling's paper that he wrote many years ago about phase relationships in the standards process is a good way to think about when to standardize. And I think it's very appropriate in the consumer electronics world, because I've seen this many, many times. He had a model where you look at technical activity and what he called political activity, so you can see where his head is at with regard to standards. If you integrate technical activity, you get knowledge. And if you integrate political activity, you get calcification, what he called calcification. So subtracting the two numbers gives you the sensibility of standardization. If the knowledge precedes calcification, standardization is sensible, and there's a fairly wide period of time when you could do a standard. You don't really know exactly when to do it, but anywhere along that line, that flat SS line, standard would be positive. That's not necessarily a good scenario because you don't really know when to do the standard. You could disagree with it. If the political activity precedes the technical activity, you have a negative sensibility of standardization. So it's equally bad anywhere. You don't want to do that. So a question that we could talk about is, where are we today in cloud computing? I believe that we're developing knowledge. It hasn't calcified. We can create standards that help the industry develop and grow, but it takes federation. And the second kind of federation I wanted to talk about, and shortly we'll open it up for questions, is the federation around the IEEE. And that is what the Cloud Computing Initiative was designed to leverage. We've brought together societies, councils, standards, and other activities, publications, education, and so forth, across the IEEE as part of the Cloud Computing Initiative to leverage the tremendous resources that the IEEE has in developing a sustainable advantage for IEEE in the cloud computing space. I mentioned earlier some of our publications. We're going to be announcing the IEEE Cloud Computing Magazine, and shortly thereafter, IEEE Transactions on Big Data. These are the three publications that we in the Cloud Computing Initiative have spun up with a collaboration of multiple units across IEEE. We've also have an education program with a substantial body of knowledge around cloud computing that we're putting together in cooperation with IEEE and EAB, Educational Activities Board. We're obviously working with IEEE conferences all around the world, and this is part of it, to cooperate, share knowledge, and get knowledge from the societies across the IEEE. And in fact, we put together 7 tracks in the Cloud Computing Initiative to do that. Conferences, publications, education, standards, big data, testbed, and the web portal that I mentioned, cloudcomputing.ieee.org. Please look at that and drive up our numbers. And we also have Twitter and LinkedIn and Facebook and probably a bunch of other social media. All of these things are a volunteer staff partnership. Each of the tracks has a volunteer staff lead, and we'd love to have more participation from you going forward in the Cloud Computing Initiative. This is our final year of the Cloud Computing Initiative. 2014 is the third year, but we have some really exciting developments going forward this year, in particular the testbed going live, the second and third publication being announced. All of them will be leveraging the tremendous resources across IEEE in the cloud computing space, and we'd love to have you help make this fourth wave of computing, this third platform, successful, so that when people are talking about the Vint Cerf of the future, it's somebody in this room who is talking about being there when the intercloud was created and making this a resource that will help all of humanity, which is the IEEE's tagline, advancing technology for humanity. That's what we want to do. That's why the Cloud Computing Initiative was founded. And visit cloudcomputing.ieee.org and become part of it. Thank you very much. And I'd love to have some questions.
That was wonderful. Is this a live mic?
No.
I can hear you.
Yes, we can hear you.
Yes? Okay. I was thinking, I love your comment about how the future doesn't repeat itself, but it rhymes. And I think another way of thinking about this, and feel free to run with any analogy that works. We went through some of the same history. I was at Atari buying your Cinertech chips. And if you think about this from the point of view of the user, the applications developer is the proxy for the user. We went through machine-coded things, 6502 assembly language.
Great processor, by the way.
Yes. Then we went through high-level languages, so we had standards like C. And then we went through one or more operating system middleware standards, so we abstracted, let's say, the printer driver from the application that wants to print something on the screen. And then we went through standardizing how devices talk to each other over the network. TCP/IP was the big winner there. And we're moving forward to trying to abstract in another way. Your intercloud, to me, sounds like an abstraction, more middleware for the entire cloud as opposed to a single computer. Does that help clarify things at all?
Well, I think that's an excellent way to think about the intercloud. In other words, it's sort of the internet writ large. It's a new platform, just like you've outlined the platforms that we've lived through, loved and suffered through going forward. You don't have to know assembly language anymore to take advantage of that. I think the vision that some of us had was that we want to make it possible to write applications for the whole cloud without knowing where they're going to run. So when you were at Atari writing 6502 code, you had to know where the scan line was. You had to have knowledge, which was 50% or more of your thinking just to get it to work in the first place. You had to be a genius to make anything work, and then you only had a small portion left over for the application itself. And so what we're trying to do with the intercloud is compress that knowledge that's needed to write applications for the whole cloud so that you can put most of your thinking into what is the application. And that'll benefit both the cloud providers because it'll explode the demand. It'll benefit the users even more because those applications will be things that we can't think about today. And by the way, I think that's something else that I've learned in my career, and that is, it's not what you can think about, it's what you can't think about that really creates the future. I remember in the early days of TCP/IP, there wasn't a concept of a firewall. Why was that? Why was there no firewall? Well, maybe we'll find out. because everything had to have an IP address. Well, firewalls don't have IP addresses. Packets flow through firewalls without having IP addresses, and the firewall munges packets going through. That market didn't exist, and we didn't have that in TCP/IP, and so we don't know what we don't know. In architecting the future, you have to keep that in mind, and of course, I don't know what I don't know either. So, next question.
Okay, is this on?
It's on.
Okay, first, 6502, wonderful processor. We can have a long discussion on that.
No, let's not.
Okay, no. Firewalls, you missed the point. I did not mean to put them there. The NAT in the home was not meant to be a firewall. It's a temporary kludge. So let's forget firewalls and get rid of them. Okay, now that I've had that said, we'll discuss that longer. The cloud is an echo of the information utility. But the question is one of
Could you hold the microphone a little closer?
Okay.
So you can be
sorry,
louder?
after that rant on firewalls, it's just a hot point. I want to know about the economics of normalizing the cloud. Because once you remove any differentiation, sort of how do the cloud providers differentiate themselves economically? And I think that's the concern at this point is there's some markets where you normalize remove differentiation works very well, but how does that play out in the economics of the cloud?
Well, I think that's an excellent question. The cloud providers, as we've seen with service providers in cellular, in internet, in power, in water, etc., have different financial incentives, and they may choose to differentiate themselves in different ways. If there is no intercloud standard, of course, then the intercloud option is not available to service providers, or they'd have to create one. What will make a difference for the service providers is for customers to ask for the ability to write applications that go across the whole cloud. And customers asking for that will create an incentive for the cloud providers. They may not all initially join. They may feel that they're the leader in a particular space. They may have what they see as a de facto standard, and so they may not want to have multiple cloud providers competing with them. But it's the users that make the difference. And we're creating the opportunity for the users to ask for a way to write applications that run across the whole cloud.
Okay, next question.
Thank you.
I want to ask this. Do you see a cloud at the home environment? The thrust of my question is really trying to address the relevance of cloud interface, API. You mentioned about the timeliness of the cloud computing standards. I would like to raise the issue of relevance of cloud computing standards with respect to consumer electronics, particularly.
That's a great question. Consumers are already using the cloud today. When you log on to TurboTax or Quicken or Google or any of a number of providers, in many cases the assets that these providers are using are cloud assets. The question is, as an application developer, who's, as was said earlier, think of them as an intermediary to the user. Do those application developers have the ability to compose assets across the entire cloud and create applications that the user would like to have, would pay for, and so forth? And we think that creating a standard like P2302, and there are others, would make that happen and ultimately drive value to the user. There is a concept of hybrid clouds where a local cloud, a local data center, or maybe a cloud at public cloud when it needs extra assets. And there are efforts that have been underway actually for many years to build what have been called home servers that ultimately today would probably be built in an architecture of hybrid cloud or bursting cloud. Your smartphone is a cloud provider, and how the smartphones are integrated into large service provider clouds today is all proprietary. It doesn't have to be that way, and we hope in the future that standards like P2302 will enable that. Yes,
Yeah, my question has two parts. Part one, how is your approach would differ for single users or for organizations? Okay, lots of work now being done for providing cloud services for organizations, look IBM, Amazon, Google, and so on and so forth. How would they differ? A. B, the second part is, what makes you think that the big companies, the cloud providers, are going to listen to what IEEE says? Do they listen or they don't? And if not, what does it make for them to listen to what IEEE is going to say? Maybe they have more experience than IEEE people on those matters.
Well, I think the people that listen to IEEE are listening to IEEE because they see there's a business case to be made for implementing this standard. People before 802.11, which is one of the most successful IEEE standards, by the way, there was 802.3 before 802.11. I don't know how many people remember we used to have wires that people plug in. People didn't implement 802.11 because they wanted to listen to IEEE. People already had proprietary wireless interfaces. But what happened is the customers demanded a standard wireless interface, and that's what caused the marketplace to explode. Before 802.11, there were a number of many vendors. I had several of them myself. I always seem to collect the proprietary losing standards in my particular garage. But 802.11 made the market explode, just as 802.3 made the wired networking market explode. Vendors will implement the standard if customers ask for it.
Steve, Tom Wilson has kindly and firmly on the last question, and about a 1 minute answer if you have time. One presentation, what are your ambitions, your hopes for there being either a standard or some recommended practices so we don't get more of the email situation of 1983? What's your hope for a timeline here, please?
Well, my hope is that in 2014 we have at least the first balloting of P2302, the Intercloud Interoperability and Federation Standard, that we have the Intercloud testbed up and running so that people can find problems with P2302 and fix them before they're finished, and that we have P2301 so that I don't have to keep making my own chart about important standards that I get tired of updating all the time. I think in 2015 we'll start understanding where these things are going, and we'll have an idea whether we're going in the right direction or not. Probably it'll be too early to be sure, but we'll start having a fairly good idea of the directions. If you look at the other standards developments over time, there's a really interesting scenario where it takes much longer for these changes to occur than the people who are in the middle of the technology think. And it always seems like it's too late for all of us who are intimately involved with the technology, and at the same time it's too early. So I think that's one mistake that those of us who are really closely involved with the technology tend to make in terms of the timing of the development of these standards. And that's why I think you see see companies investing a tremendous amount of money in something that goes nowhere, and other companies that seem to stumble on something that explodes. Part of the reason is that those of us who are in the middle of it find it difficult to understand the timing. It's better for somebody who's not quite in the middle, like, for example, you are, to look at it slightly from a distance and have opinions that even the folks of us who are doing the soldering and the wire wrapping can't have because we're too close to it.
Thank you.
Is this slide? Yeah, good. Steve, I want to thank you too, but I want to jump in here for a second in my role as Vice President of Publications for the Society. People may have noticed Steve had a CSOC logo up on that, but people may not be aware that we are a financial stakeholder in the new transactions on cloud computing, which gives everybody a little bit of a break on subscribing to it. And we also have a steering committee seat. And I just wanted to find out whether there is somebody who is more qualified and interested than me in actually being our representative on the steering committee, where I'm currently the placeholder. But Steve, thank you so much for.
Thank you.
Steve, thank you for a most insightful talk. On behalf of the ICC committee, we would like to present you with a small appreciation, token of our appreciation.